Why doesn't this giant hunk of metal fall out of the sky? So I have a quick way for you to understand the basic principles of airplane flight in less than 10 seconds. Next time you're in the car driving down the road, stick your hand out the window. Keep your hand flat and level. You shouldn't feel any particular upward or downward force. Now tilt your hand upwards by a few degrees and suddenly you'll feel a much greater upward force on your hand, and vice versa if you tilt your hand downwards. This essentially is how planes fly. You can think of the wings of the plane much like your hand in this scenario. When you stick your hand out the window while traveling fast, your hand is rapidly colliding with air. If your hand is level, then you're colliding with roughly equal amounts of air on both the top and the bottom of your hand. But when you tilt your hand upwards, suddenly the bottom of your hand is colliding with much more air than the top of your hand. Because of the angle, all the air you're colliding with is diverted downwards. And because of Newton's third law, every action has an equal and opposite reaction. This enacts an equal force on your hand in the opposite direction. This is how planes generate lift. A plane uses propellers or jet engines to propel itself forward at a high rate of speed. Due to the shape and angle of the wings, the air they collide with is pushed downwards, which in turn pushes the plane upwards, aka lift. The faster the plane goes, the more lift is generated. Once they hit a certain speed, the wings are able to generate enough lift to pick the plane up off the ground. Okay, great, we're in the air, but quick question, and it's kind of important. How the heck do we control our movement now? Well, pretty much using the same principles. You can understand most flight on Earth by understanding this. Push air in the direction opposite of where you want to go. Wings, jet engines, rudders, ailerons, elevators, we'll cover what all those are in a moment. All of these things work by following this principle. Let's talk about turning first. Let's say we're in the air and we want to rotate our plane. Considering the anatomy of the airplane, how can we do that? Using this. It's called a rudder. It's a vertical piece that sits on the stabilizer that can rotate outwards left or right. By flipping it out one way, we can push the air that collides with it in a certain direction. Just like wings generating lift, the equal and opposite force of pushing this air pushes the tail of the plane in the opposite direction. This is how we control what is called the yaw of the plane. Assuming we're inside the plane facing forwards, moving the rudder out towards the right will move the tail of the plane to the left and therefore the nose of the plane to the right. But here's the thing about rudders. They rotate the plane, true, but they don't actually alter the motion of the plane much. Even if you rotate the plane to the right, it will most likely continue going straight, so they're not really used much for turning. They're great for making small corrections and keeping your plane flying straight in a crosswind, but what about if we need to make an actual turn? Actually alter the course of our travel? Well, you know how wings are so good at pushing air that they can literally pick this giant contraption up off the ground? Wouldn't it be cool if we could somehow leverage that into helping us turn? Well, we absolutely can. But to do this, we need to change the direction that the wings are pushing the air. To do that, we need to roll the plane onto its side. We can do that using these. They're called ailerons, and much like rudders, they are pieces that are on hinges and can rotate upwards or downwards to direct air. They operate in tandem with each other by moving in opposite directions. If we want to roll our plane to the right, the aileron on the right wing will move up and the aileron on the left wing will move down. The difference in the forces here make the right wing move downwards and the left wing move upwards, rolling the plane. Now that the plane's on its side, you'll notice that rather than the wings moving air directly downwards, they're now pushing air to the side. This lets our airplane turn much faster. Alright, great, so we've covered how to rotate the plane left and right, how to roll the plane, but how do we control how high we're flying? This is where I introduce you to elevators. Similar to ailerons and rudders, these are hinge pieces that sit horizontally on the tail and can be used to control the pitch of the plane. Moving the elevator upwards pushes the tail downwards and therefore the nose upwards, and vice versa. So when we're trying to gain altitude, we pitch the nose of our plane up so that our wings can generate even more lift, although we do sacrifice some speed by doing this. The last piece we'll talk about are these. They're called flaps. These are also hinge pieces, but rather than being used to change the orientation of the plane, the purpose of these is to alter the shape of the wings, usually by increasing surface area, to increase the amount of lift the wings can generate. When fully extended, they allow wings to push significantly more air, which reduces the necessary speed for the plane to become airborne. The downside of flaps is that they greatly increase the amount of drag the plane experiences, so once we're in the air and up to speed, we can retract them to reduce drag. These are generally used only at takeoff and landing to reduce the amount of distance needed. And that's pretty much the basics of airplane flight. Again, this was a very simplified explanation that will leave pilots and physicists rather upset, but now you can at least hopefully conceptualize it better. Before you go though, I'll leave you with a question. If planes utilize wings to generate lift, how are things able to fly without wings? For example, helicopters. Well, that's what we'll cover in my next video.